Welcome to Mr. Chalk's Revision Tips. In this video, we will look at
potential difference in series, and potential difference in parallel. So, as electrons move around the circuit, they gain or lose energy. So, potential difference is a measure of how much energy of the electrons changes as they move from one position to another. So electrons gain energy as they move through the battery. Electrons lose energy as they move through other components like bulbs. And we measure potential difference of using a voltmeter, and we measure it in volts. So Ohm's law is the equation that gives us voltage. That would be one way to do it, right? The other way to go and work out potential difference is using power is equal to potential difference times current. So when we rearrange that, we get power divided by current is equal to potential difference. So an example would be, what is the potential difference with a power rating of 75 and a current of 15 amps? So we'd rearrange it to potential difference is equal to power divided by current. So that would be 75 divided by 15, which would give us a potential difference of 5 volts. Potential difference is measured using a voltmeter. The voltmeter must be connected in parallel to the component. The voltmeter is connected in parallel because it has to measure the potential of the electrons before and after passing the component. So the potential difference in series and parallel circuits is different. So in a parallel circuit, the voltage always stays the same. However, in a series circuit, the voltage is split over the different components. So the potential difference in a series circuit is the potential difference across the battery is equal to the sum of the potential differences across all the other components. So when more components are added, the potential difference across each will be lower. So this is why bulbs are dimmer when they are connected in series. If the components are identical, the potential difference across them will also be identical. So if we look at this, so if we want to calculate the voltage at voltmeter 3, we would have our original voltage from the cell divided by 2, which would give us 1.25 volts. In this one, same again, voltage at 3, you've got two components, so it will be 6 divided by 2, which would give us 3 volts. This one, 8.4 over 2, same again, divided by 2, which would give us 4.2 volts. In this example, we're starting off with 15 volts, however it's been split over 3 components, so the voltage at 3 would be 15 divided by 3, which would be 5 volts. Same again, 18 volts to start off with over 3, which would give us 18 divided by 3, which would be 6 volts. This one, same again, 21 over 3, 7 volts each. So if we're looking at the behaviour of potential difference in a parallel circuit, so the potential difference across the battery is equal to the sum of potential differences across each branch on the components of the circuit. So components connected in parallel have the same potential difference as the battery, no matter how many branches are added. So this is why bulbs stay brighter if they are put in parallel. So if we look at this example, we look at the volt in voltmeter 3. Because voltage remains the same in parallel, it's also going to be 10 volts. In this example, however, because we've got two components over that arm, we're going to have 10 volts. However, it is going to be divided by 2. So that would give us a potential difference of 5 volts.
Thanks for watching.